We live in a world fraught with competition. And when people are enhancing their skills with agentic AI, in order to differentiate yourself from the masses, you need to learn how to learn, become an expert at taking on new tasks. Adaptability is what is going to allow you to thrive in this type of an environment. If you're interested in networking and specifically like data center AI ML type networking, in this video, I'm going to walk through using EVPN and VXLAN. All right, let's get to it. Here's the landing page. We're going to select EVPN VXLAN. I'm going to have the topology deployed. It's using Container Lab in the background, using a YAML-based manifest file to spin up the topology. Here we go. We've got one spine, 2 leaf nodes, and 2 edge nodes. If this works, at the end of it, we'll be able to ping from edge 1 to edge 2, traversing our very tiny fabric. The way you connect to these nodes is just clicking here, and then you get a shell. You can also use a terminal. This is the multipass VM, and you can see here I've already got the containers. Like what you could do, we could drop into the spine here using a docker exec command. All right, you have all the Linux commands available to you here. Like if I want to list out the interfaces, if I want to see the addressing on the interfaces, if I want to look at a forwarding database, there you go. We'll come back to this in a minute. Let's use the UI. I think it's important to understand why you might be interested in this particular design. So to help out with that, I've got references to RFCs. I'm going to pull one up. We can take a look at it quickly. So VXLAN. Why would we be interested in VXLAN? If you click here, it'll pull up a new page. The VXLAN problem statement. You can just read some of these headers. I do encourage you to actually peruse this entire RFC. It's great. This is where you learn the intent and the spec behind the particular protocol. So initially, we're trying to address some limitations imposed by spanning tree. Well, why do we not use spanning tree in a data center fabric? In fact, why do we not use spanning tree in most data centers? Well, the reason is spanning tree by design, it inherently blocks. Let's say you've got redundant paths. You've got multiple paths to get from a source to a destination. With spanning tree, one of them is going to be blocking. It does that. It's very nature. All right, so to address some of that, VLAN ranges, it's 2 to the 12th power. If you need more hosts in a particular subnet or VLAN than that, you can use VXLAN. Multi-tenant environments. Inadequate table sizes at the top of rack switch. And then we've got VXLAN, where it actually goes into the mechanics, VNI. We'll take a look at some of this information here shortly. Or I'll leave it for you to run through the lab whenever you have your own free time. Let's get back to the lab. So I'm just gonna, you can read through this later. I'm gonna run through it pretty quickly. I'm getting ahead of myself. Let's look at EVPN. EVPN, all right, so it talks initially about virtual private LAN service. Well, VPLS was the traditional way of extending a layer 2 subnet across a layer 3 environment. VPLS was a data plane solution, right? You could potentially have a broadcast storm, and it would impact your entire core or whatever subnet of the network it actually traverses, where that configuration lives. EVPN is a control plane solution. So we're now pulling broadcast, unknown unicast, and multicast or bump traffic out of the data plane and putting it into a BGP update message as network layer reachability information. Again, read through this RFC. It would behoove you. It's a good idea to understand the why and how these protocols are designed. Let's just go on to the next section. Verify, underlay, BGP. All right, I'm going to use this little interactive session here. So I'm currently in leaf 1, and it says to drop into the VTY shell. Let's do that, and then you can run a couple of different commands. Actually, to give myself some more real estate, let's pop this over and that over. All right, now we got some more space. You can run show IP BGP summary. You could also ask for the AFI, or the address family identifier, the subsequent address family identifier. You get the same output. And interesting with FRR, it shows you, or actually this is the description, but it's got the spine 1 in here, which is pretty cool. You could see that we've got appearing to the spine. We could log into the spine and we could see both the leaves. The way this architecture is designed, the leaves don't peer with each other. We could do like a multi-hop external BGP peering. We could set this up in a number of ways, but I've kind of tried to make this as simple as possible. We will log into the spine though. Another way of doing this, just to give you options, you could, you don't have to drop into the VTY shell. You can run it straight from here. IPv4 unicast summary. And interestingly, if you wanted to only look at leaf, you can actually grep, because we're not in the VTY shell. And whoops, well, you got to spell grep correctly. And now we have a subset of the overall output. Step 2 is knocked out. Let's go on to creating the bridge and the VXLAN interfaces. Leaf 1, leaf 2. I'm just going to quickly grab this configuration. The idea here is to kind of give you a sense of how to use this UI, how to use this tool, not necessarily to walk through all these concepts in great detail. Let's expand out leaf 2. Again, I'm just going to copy this, paste it in. All right, enable EVPN AFI SAFI. Let's go to the spine. This should all just be copy paste. There we go. I guess maybe to quickly cover this. This is stemmed from grouping nodes together. This was a Cisco ILS feature initially. It seems like there are a number of C-lish or Cisco-like shells out there. Aristas is very Cisco-ish. FRRs also adopted that same look and feel. Let's go to leaf 1. Again, we will just copy and paste into leaf 1. Let's go to leaf 2. I'm going to click, paste. Leaf 2 has this configuration. All right. Let's take a quick peek. Since we're on one of the leaf nodes, we'll just do show BGP LTVPN summary. We have a peering up, and we have 2 prefixes that we sent and 1 prefix received. If we remove summary, you can see the routes. You can actually ask for the type of these routes. Route type. Type 2 is the MAC or IP MAC route. We don't have any. We haven't actually generated any data plane traffic. We do have some type 3 routes that you can see here coming from the leaf nodes. Let's keep going here. Map interface on the bridge. So if we came back over to, actually already on one of the leaf nodes, we could take a look here at some of these commands. Here we go. We can look at the VLAN. Oops, let me get out of the VTY shell. We could also say, give me the forwarding table. Let's actually generate some traffic and take a look at a type 2 route. So validate end-to-end connectivity. Let's send a ping. All right, we got a response. Now if we come back up to the leaf, we can drop into the shell. And this time when we look for type 2 routes, we've got 2 type 2 routes and then the MAC addresses. If we were to come back, so you could tell this route is local, right? This one came from leaf 2 since we're on leaf 1. If we were to look at our local MAC address on edge 1, it would be this MAC. Before I get off of here, we'll just take a quick peek. You can say show EVPN MAC, VNI all. There are the MAC addresses, and you can see local. It's the same address that I've got in the clipboard here. And if we were to hop off of the leaf node, actually log out, we need to go over here. We can say IPL, and then there's that same MAC address. We can say IP neighbor, and we've learned the remote MAC address. Awesome. Actually, I'm going to save the Wireshark capture bit for another video. This one's probably already longer than I anticipated. Here's Lab Builder. Pull down the repository. I'll have a link to it in the description section of the video on YouTube. If you've got any questions, let me know. You can add a feature request into the repository if you've got some ideas. If you find a bug, submit a bug request. I threw this together to mostly help myself, but hopefully you can benefit from it as well. Have a good one.